The next question is, the precipitate of silver chromate KSP value is given as 9 into 10 to the power minus 12 is obtained when equal volumes of following are mixed. Option A, 10 to the power minus 5 molar Ag plus 10 to the power minus 3 molar chromate ion. Option B, 10 to the power minus 5 molar Ag plus 10 to the power minus 2 chromate ion. Option C, 10 to the power minus 4 Ag plus 10 to the power minus 2 molar chromate ion. Option D, 10 to the power minus 7 molar Ag plus and 10 to the power minus 3 molar chromate ion. The question is based on the precipitation, and we know the condition for precipitation. The condition for precipitation is the product of ions present with us, that is we call it as QSP or ionic product, should be greater than KSP, that is solubility product. So they have given you certain concentration of Ag plus and chromate ion. For those concentration we should calculate the product of ions, which we call it as ionic product. So if the ionic product exceeds the solubility product that is given, then the precipitation takes place. Okay, one by one we will try to calculate the ionic product. Now for option A, ionic product is given as QSP. It is defined same as KSP, where the concentration of ions need not be the concentrations in a saturated solution. So silver chromate on dissociation gives you 2 silver, so it will be Ag plus raised to 2 Cr2 minus raised to 1. So option A, it will be 10 to the power minus 5 Ag plus raised to 2 into chromate ion, that is 10 to the power minus 3. Since they have mixed equal volumes, when you mix equal volumes of Ag plus and chromate ion, so the concentration reduces to half. So it will be divided by 2. This also will be divided by 2. So this will be equal to 10 to the power minus 10 square into 10 to the power minus 3 into 1 divided by 4 into 2, 8. That will be equal to 0.125 into 10 to the power minus 13, that is nothing but 1.25 into 10 to the power minus 14. The value of QSP obtained for option A is less than the KSP value given. KSP value is of the order 10 to the power minus 12. Hence here QSP doesn't cross KSP, hence you don't get a precipitate in this equation. Similarly, if we take the second option B, so if we calculate the QSP value for option B, QSP is equal to concentration of Ag plus, that is 10 to the power minus 5 raised to 2 divided by 2 into concentration of chromate ion, that is 10 to the power minus 2 divided by 2. This will be equal to 1 by 8 into 10 to the power minus 12, that is nothing but 0.125 into 10 to the power minus 12, that is 1.25 into 10 to the power minus 13. This also value is less than KSP value, hence in option B also the precipitation does not take place. Let us look at option C. For option C, the QSP is equal to, same you can calculate it, concentration of Ag plus raised to 2, that is 10 to the power minus 4 divided by 2 raised to 2. Why it is divided by 2? Because we have mixed equal volumes. When you mix equal volumes, the concentration decreases. For option C, QSP is equal to 10 to the power minus 4 divided by 2 whole raised to 2. Why it is divided by 2? Because we have mixed equal volumes. When you mix equal volumes, the concentration reduces to half. Why it is square? Because silver chromate on dissociation gives 2 silver ions into the concentration of chromate. Concentration of chromate is given is 10 to the power minus 2 divided by 2. This will be equal to 1 by 8, that is 1 by 4 into 1 by 2 into 10 to the power minus 8 into 10 to the power minus 2. That will be equal to 0.125 into 10 to the power minus 10, that is nothing but 1.25 into 10 to the power minus 11. The value of QSP obtained for option C is greater than the KSP value that is given. Hence here precipitation takes place and option C is the right answer. The next question is pH of 0.10 molar solution of a salt NaX where HX is a weak acid is 8.35. The dissociation constant of weak acid HX is option A 3 into 10 to the power minus 4, 2 into 10 to the power minus 4, option C 2.5 into 10 to the power minus 4, option D 3.5 into 10 to the power minus 4. NaX is a salt of weak acid. On hydrolysis, NaX gives NaOH plus HX as follows. NaX on hydrolysis will give you NaOH plus HX. They have mentioned that HX is weak acid, NaOH is a strong base. Hence, pH of this can be related with the pKa as pH is equal to half of pKw plus pKa plus log C. This equation we have discussed for how to calculate the pH of a salt made up of strong base and weak acid. So, pH is equal to half of pKa plus pKw plus pKa plus log C. So, we need to calculate the dissociation constant, that is Ka. From this equation you can calculate pK. Once you calculate pK, you can easily calculate the value of Ka. The pH value given is 8.35, that is equal to half of pKw is 14 plus pKa value, that is what we need to calculate pK, then we should calculate K log C, that is C is 0.1, that is 10 to the power minus 1. This will be equal to, if I take the three other side, it will be 8.35 into 2 is equal to 14 plus pK log of 10 to the power minus 1 is minus 1 log 10, that is pK will be equal to 8.35 into 2, 14 minus 1 is 13, if plus 13, if it goes to the other side it becomes minus 13. So, pKa value will be equal to 3.7 now. So, we do not require the pKa value, we require K, and you know that pKa is equal to minus log of K. Hence, pKa is equal to minus log of K, and K is equal to anti-logarithm of minus pK, that is K is equal to anti-log of minus pK, that is anti-log of minus 3.7. We know that you cannot calculate the anti-logarithm of negative values, hence you should convert the mantissa part into positive by adding and subtracting 1, that will be equal to anti-log of minus 3.7 can be written as minus 3 minus 0.7 plus 1 minus 1. We require the mantissa part to be as positive, hence I will combine minus 0.7 with 1 so that it becomes anti-logarithm of minus 3 minus 1 is written as 4 bar, minus 0.7 plus 1 is plus 0.3, that is nothing but 0.3. Now, that is equal to anti-logarithm of 0.3. We know that log 2 is equal to 0.3010. So, anti-log of 0.3 will be equal to 2 into 10 to the power minus 4. Hence, option 2 is the right answer. Students, in this session we have covered most of the points. We have discussed how to calculate Kc, how to calculate Kp, relation between Kc and Kp, common ion effect, Le-Chatelier's principle, calculation related to pH, pOH, buffer solution, calculating the equilibrium constant, precipitation, solubility product. So, we have covered almost all the aspects, but still I request you to refer some good books and solve some more problems so that it will be helpful for your CET, JEE as well as NEET. Thank you.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.